Hey everybody, how's it going? Stoner Dave here, and I was going to demo this overdrive distortion pedal here, but I saw the video from Detroit Wrecker where he's claiming that he's going to build one that's going to blow this one away. So before I demo it, I want to see what he has to offer, because my instincts are telling me Detroit Wrecker is going to put out a Tube Screamer clone. Claim that he built this thing all on his own and try to take credit for other people's work. Kind of like he did with the Rob Robinette deluxe build, you know, where he bought a kit for a Rob Robinette and then claimed that he went through and made all this stuff himself. And you could tell that he'd bought the kit because, well, you look at the website, right? You go onto the website, you'll see the kit and you'll see how the components are arranged on there. And then you'll look at his build and you'll see the exact same kit on his build. See, if I were to take this right here, right, give somebody a breadboard and the schematic for this build and say, hey, make this circuit, they would make something that looks completely different than this. Some of the components would be spread out more, some of them would be closer together, but they would be completely different from this, and you'd be able to tell mine and theirs apart just by putting them next to each other. Same components, same arrangements, completely different builds. That's because people think of things differently. Now, when Detroit Wrecker put his Rob together, he didn't vary it one iota from the website. The board, same size, color, everything. Not one speck of originality to it. What does that mean? Somebody else made it. He takes credit. Says, oh, I drilled these holes. Bullshit, you didn't drill shit. You may have made the enclosure, right? But that's not difficult at all. And I seen your video where you're talking about, oh, you can't engineer this stuff from bullshit. You take it, you say, oh, here, I need a hole here, I need a hole there. It's fucking simple. I do this shit all the time. It's fucking simple. In fact, before he posted the video, made it public for that Rob Robinette build, I had said to myself, I said, he's not going to finish it because he can't get rid of the hum. Then I watched the video, and sure enough, he had made the video months before he made it public. When he made it public, there he is on there talking about the hum and how he can't get rid of it. And he's just, at the end of the video, he gets all upset and stops the video. And I understand why he took so long to make it public, because he was embarrassed. I could have told him he was going to get that hum months ago. Tell him how to get rid of that hum. I still could tell him how to get rid of that hum, but I'm not going to. The answer is actually on the website. It's in all the paperwork that came with his kit. It's all right there. It's not my fault. He's not smart enough to look that shit up or to understand what he's looking at. Now, we could talk more about speaker impedances and the resistance, but it doesn't seem worthwhile, right? I've already explained it twice. Don't understand it. It's not my job to teach you. But I will say this. we measure the impedance, or I should say, if we measure the resistance of this speaker, it's going to be about 7.2-ish. Capacitance, maybe a microfarad or so. The inductive reactance is going to be maybe 100 microhenry. And we look at the audible spectrum, because that's what this thing is going to be used as, the audible spectrum. It's between 20 and 20,000 hertz. Typically they're tested in the middle of that, give or take. 400 hertz is what most components or amplifiers and speakers are tested at. And at that level, the overall impedance of this, 7.2 ohms. Now, I have other speakers here. I got another 8 ohm that measures at 7.4 ohms. And it's got inductance of around 100 microhenry. And at that frequency, it comes out to about 7.8 for its overall impedance. And you take a look at all these different speakers, you'll find that some of them do in fact have 8 or more ohms of direct resistance. They're 8 ohms because that's a power of 2. All speakers are sold with a power of 2 as far as their impedance rating. Impedance changes with frequency. Higher frequency means higher impedance, lower frequency is lower impedance, typically, because it's an inductive load. What'll get you is when you're looking at your amplifiers, right? Your amplifiers, if you're using a tube amplifier, you have a transformer that's going to match the impedance for you. But a solid state, it's going to be resistors and capacitors being used. Capacitors are used to match the induction. Maximum power transfer theorem. I know it's been a while since I've talked about that. It says you get your maximum power when you have your impedances are complex conjugates of each other. Inductors, inductive reactance, positive J factor. Capacitors, capacitance, negative J factor. When you have something that's a complex conjugate, that means that the J factors are going to be opposite of each other. So if you have an inductive load, your source needs to have a capacitive impedance on the output. It's that simple. It's the maximum power transfer theorem being used to its fullest effect. If you don't believe me, check out the schematic for the Marshall MG10. I think that's the name of it. I have to look again. Let's see. Yeah, Marshall MG10. You look at it, you'll see on the schematic there are 4 33 ohm resistors in parallel feeding into a 220 nanofarad capacitor, and that is going to be in parallel with the 680 ohm resistor in series with a 10 microfarad capacitor. you do all the math and everything, you'll get approximately 8.1 ohms of resistance. And well, I can't do the capacitance in my head, but it works out there. And speaker, you know, whatever the speaker is going to have its inductive reactance, and the capacitors are there to give a negative J factor to offset the positive J factor of the inductive load of that speaker. Maximum power transfer right there. All right, so like I said, wait for Detroit Record to put his video out so I can demonstrate this for you. And, you know, I've already listened to this. It sounds phenomenal. I'm waiting for Detroit Record to do his video so that I can do mine. And I think what I'm going to also do, just because, I think I'm also going to make myself one of these Tube Screamer clones. Put that on a breadboard. And it'll sit next to this one, you know, test them both in the same video. And I've got one more idea for a distortion type pedal. Something that will really highlight the day. Well, got a couple of them, you know, because this is technically this is an overdrive pedal, and the Tube Scream is an overdrive pedal. He's talking about a distortion pedal, and there is a slight difference between the two. If you're not familiar with the difference between an overdrive pedal and a distortion pedal as far as the electronics are concerned, don't feel too bad. Not a lot of people are aware of these very minute differences, but I'll be more than happy to go over that with you when the time comes. Like I said, I'll wait for Detroit Record to put out his video. I mean, if his mom will let him do the video, that'd be great. I know she lets him use the basement so he can shoot his videos, and he's got a nice little workstation there in his mom's basement, which is really nice. You know, I'm glad his parents let him have that area. My parents weren't so kind, I suppose. Not really that they weren't kind, it's just that we lived in Arizona, we didn't have basements. I guess Detroit, here in Michigan, they have basements. So, c'est la vie. So, until Record puts out his video, the most I can do is show you this and talk about the components. So, in the meantime, thanks for watching. Have a great day.